think what I'd like to do is start with a very short video clip. And in the short video clip, the question is, how many professors does it take to screw in a light bulb? Well, you can see the answer is none. It takes no professors whatsoever to screw in a light bulb because we were able to program and fly drones to be able to accomplish this task. In fact, there are many tasks that we can accomplish using the new technology of drones. So what I'd like to do is spend the next 45 minutes or so talking with you about the kinds of things we're teaching students and their teachers how to do with drones as we move them in through STEM pathways. So these STEM career pathways, when I say STEM, what I'm saying is science careers, technology careers, engineering careers, mathematics-based careers. And there's a lot of effort across the country, really across the world, and have been for a number of decades, trying to improve the number of students and the diversity of students that try to find pathways into STEM careers. And this is pretty serious. I mean, we're talking the U.S. government is spending a tremendous amount of money every year to try to accomplish this. The National Science Foundation dedicates more than $100 million each and every year to trying to fill the STEM pipeline. NASA, $50 million a year, particularly with their aerospace and earth sciences programs. Philanthropic organizations, NIH, a tremendous number of pathways. But it's not just federal government agencies that are trying to find ways and putting money towards this. There are also a number of commercial entities. For example, some of you may have been involved when you were in high school at the International Science and Engineering Fair. This is an engineering fair that has, at its final event, 1,500 presentations. 1,500 participants giving presentations, much like a scientific conference poster session that you might be participating in, well, in a time when we're not related to the pandemic. And these students are competing for $4 million in prizes and scholarships. So the amount of energy, the amount of money that's being thrown towards increasing the number of students that are following STEM career pathways is enormous. And one place we see a lot of this in recent years is in the nature of robotics and in the nature of remote control. Some of you may have, when you were in school, participated in Lego robotics, First Lego League, VEX robotic systems, in which student teams are given a challenge at the beginning of the year of something that they need to be able to accomplish by building a robot and by computer coding a robot to complete a particular task. And that task changes every year. And these competitions are big. They're held throughout Wyoming. There are 7 or 8 around the state, as well as a state championship. Lego robotics is very, very popular. Similar to Lego robotics, there's BattleBots, which actually has its own television show. This is where students and adults create robots that are designed to destroy other robots. Yes, anytime we get close to death and destruction, that's the kind of things that capture students' attention. So BattleBots is something that's important. And in recent years, there's been the Robot Cup, the Robo Cup. And they've been doing challenges about having robots that compete in football competitions or soccer competitions. So this idea of remote control of robotic systems to do tasks is something people are putting a lot of energy in to get students to pursue STEM career pathways. Now, all of these programs work really, really well, and they are, in fact, moving students towards STEM career pathways. But each of these things listed to the side here are really focused in helping students get into undergraduate programs and graduate programs. These are the kinds of programs that are designed to take really high aptitude students and get them to finish their Ph.D.s and become a part of the world economic system related to science and technology. But it turns out these programs leave out an entire group of students that are high aptitude students, but really not students that are intending to go on to graduate programs or even undergraduate programs. These are students related to vocational education. Maybe they're students that are working on getting 2-year degrees at technical colleges or community colleges, or students that maybe are focused on vocational education, welding, programs, which of course, as many of you know, welding is often done automated these days. Agricultural programs, of which automation is an enormous part. I know some of you are working on the GPS systems related to tractors and farming and agriculture, related to fertilization issues related to crops and water movement, the hydrological cycle. So there's a lot of students that are interested in STEM-related high-tech careers, but may or may not be looking at the full robotics engineering experience. And the question is, how do we bring those students into the fold, and how do we access their talents and that diversity? And we think that drone technology may be the way to do it. We're not saying that people that have PhDs aren't interested in drones, because I know that's not true. You have people on your faculty that are very interested in drones. But is it possible that drone technology can access a wider group of high aptitude students and do a better job of rounding out and filling out the STEM career pipeline? We think it is. And there are a number of reasons for this. One is that drone technology has gotten really, really good in the last few years. Now, really good means a couple of things. For one, it means it's becoming quite inexpensive. I know some departments have spent $25,000, $30,000, $40,000 on their drones and drone systems. But now a drone can be had for $100 that'll do some pretty amazing things, either by real-time precision flying or through automation. And that includes mapping of agricultural lands, looking at different... You missed my great jokes, and you missed the part where I was giving you all the numbers for the winning lottery tickets. So you'll have to hang on till the end of the program to be able to hear that.
Sounds good. Thank you.
You're welcome. Thanks for letting me know. Sorry about the hiccup, but I appreciate your technology work here. All right. So as I was trying to argue before, drones have become relatively inexpensive. They become much easier to fly. And that's really pushing us forward because now they're accessible to K-12 schools. Also, of course, naturally, you can imagine that quadcopter technology allows us to be able to teach the physics of flight, be able to teach aviation technology, which is pretty wide-ranging. Involves looking at weather systems and aviation weather, making predictions about air movement and wind, quite a wide variety of different things that fall into place there. And of course, closer to home to what you've been working on is the mapping technology that comes related to drones. Now, the most expensive part of running a drone mapping program today really is not the drone itself, as much as it is the software. Because for a few $100s, these Mavic Mini drones can do an amazing amount of work. They can stay afloat for 30 minutes. They have a range of almost 10 kilometers for just a few $100s with these DJI Mavics, if you have the right software. So it's really, in many cases, becoming more about data manipulation in learning how to use GIS systems than it is about the flying. But the flying is the really fun part. For me, that's where you get students really, really excited, is thinking about the flying. And some of that flying can be done automatically, and some of it needs to be done by precision pilots. For example, some of you may be familiar with the drone mapping that was occurring in that you see in science fiction. For example, in the Prometheus, which is the prequel to Alien. What I want to talk about is computer coding, because there are two ways we think about drone flying. One is active precision flying, where you've got a pilot right there making sure they do all the right moves. But there's also a real push in Wyoming for computer science coding. You may know that the state of Wyoming requires all high schools to offer computer coding as part of the curriculum. Whether it's its own class, standalone class, or whether it's integrated in other classes is not clear how that's going to play out. But we can use very simple block coding techniques to teach students how to code using drones. It's totally ridiculously cool already. Any of you are familiar with Prime on Amazon purchasing? Imagine you look in California, you can get a 30-minute delivery right now in San Francisco Bay Area. Here's how it works. So we start talking about drones and we start matching that to career paths. This is what gets kids really, really excited because they can begin to see themselves in a future with drones and a reason to use drones. And this is actually where drones and drone education exceeds the highly successful robotics technology and robotics education. Because robotics education is really about building robots to do stuff. Where we start talking about drone education, sure, we're coding drones and we're engineering drones to do stuff, but the ways that which drones can be used compared to robots is immense. For example, think about ways we can support law enforcement or emergency services, the ways that we can support national parks, animal migration, and hunting, sure. How do we support a wide variety of things like prescription deliveries or medical supplies? The number of career paths that one can get into the moment they know how to fly a drone are immense. Whereas many robotics careers really do require a 4-year degree or a graduate degree, we're seeing students in high school developing programs where they work for real estate companies, or they work for construction companies, or work for railroad companies, in entrepreneurial sorts of businesses that can be done right out of their own home. So the career paths related to STEM, vocational education, information technology, really, really immense. And that's pretty exciting stuff to do. Now, as you know, with every technology, there are failure points. And those can be technical failure points, legal failure points, or even moral failure points. So as you can imagine, science fiction, which is a genre of literature and art that tries to explore some of these ideas of the human experience put in weird situations, drones play an important part. There's a brand new series out on Netflix called Omniscient. And if you've seen Omniscient, you probably think it's great. If you haven't seen it because you're terrified of what's going on with this storyline, you're probably right. It's going to keep you awake at night. Let me show you what the trailer looks like for Omniscient.
The one about the light bulb.
That you and your entire generation are used to growing up within the system.
Hear it in the audio there?
Yes.
You forgetting
All right.
that you and your entire
Thank you for whoever called that out. I think that was Brandon about the audio. Thank you very much. So, screw the headphones. Let's teach. All right. Now, the reason I wanted to be sure I got the audio version going was because I want to talk to you a bit about the relationships between the creative and communication arts related to drones. Because drones just isn't just about flying, about computer coding, about mapping. But can have a lot to do with journalism. There are several high schools in Wyoming that have journalism programs that use drones as part of their journalism program. In fact, what we've been doing, what we've been experimenting with high schools is actually having drone film festivals. And now if you do if you were to search for drone films on YouTube, you'd find tons. Don't do it right now. They're very, very addictive. But just to give you kind of a sense here, for example, we were running a film festival in Hawaii this past year, and we had students create drone films that highlighted Hawaii. Some of them turned out to be absolutely fantastic, both from an editing perspective and from a precision type perspective. Paddington, can you hear the music that's going on with that video? And can you see the video?
Yep.
This drone's doing about 60 miles per hour to give you a sense of the precision flight we're talking about here. So to encourage students to get interested in drones, part of what we've hosting film festival. So this winter, we're going to be holding the Cowboy Classic Film Festival, which will be held in conjunction with the Agriculture Education Program, and we're going to have students making videos about agriculture in Wyoming and holding a film festival with this. This works particularly well for students who are homebound. Maybe they can't travel to Laramie for a competition, travel to Casper for a competition. They can sit right out in Evanston and create a video about agriculture in Evanston and submit that electronically. People get really really good with creating a drone. And we have the one that makes Star Trek sound. Sorry, Star Wars genre. So, film festivals, really, really interesting way to go after students to get them involved in a high-tech career field that they may not normally have thought of themselves doing. But let's face it, we want to talk about what's really fun. What's really fun is racing. Ever since the second car was created on the planet Earth, the guy who owned the first car wanted to race the guy who owned the second car. And that's absolutely true with drones as well. In fact, there are national drone races. In fact, this is the Collegiate Nationals that are held at the University of North Dakota each May. And you can see you have students with drones. They've got these virtual reality headsets as they're flying around these football fields in North Dakota. Drone racing, it may not be STEM, but it is fun. I mean, it is way, way fun. So we are doing a number of drone races around the state to get students to practice flying, using their precision flight skills, and to compete against one another. But it doesn't have to be done in person. Because of the internet, we can actually do virtual racing. Much like video games, we can have students all around Wyoming sitting in their living room on their own computer racing against other students from across Wyoming. So here's a race that we hosted last year, and I want to take a moment, and there's a lot going on in the video I'm about to show you here. So let me pull it apart here. In the top right-hand corner, we've got our two color commentators who are describing what's going on in the race. On the bottom right-hand corner, we have the race track, and you can see little purple lights around there where you can see the position of the drones, much like you might watch with a hockey game where they used to put the streak behind the hockey puck, for those of us that are not really good hockey watchers. On the left-hand side, you see 4 panels, and those panels, each one of those panels shows the first-person view of what the drone pilot is seeing as they're going on their race. So I'm going to start the video here. You're going to see a lot of different stuff going on here, because I wanted to take a moment to unpack it for you.
Such a slant angle, it's more of a U-turn than a launch and a dive as it was for me in the course description. Still second place, Lonnie King following super tight behind.
We don't have to do face-to-face racing, particularly in an area of pandemics.
Taking hard angles.
We don't have to. Students can do this from home.
Oh my gosh!
Or if the students can't travel for any number of reasons, whether it's health-related, whether it's legally related, whether it's distance related,
Trucker extends his lead by just a few
students
feet
can
now.
actually compete with one another from home.
A little sloppy.
All right. So racing is very cool, but there's also the legal aspects. Turns out once you hit the age of 16 in Wyoming, you can get an FAA, Federal Aviation Administration, license as a commercial drone pilot. So one of the programs we're doing in Wyoming is helping students prepare for these, giving them practice tests. 60-item multiple choice test over 90 minutes. And so we have knowledgeable competitions in Wyoming for high school students to see who know the most rules, because everything related to aviation control is related to that. All right, so how do we put all this together? How do we make this happen? Where can you plug in? Well, one place that you can plug in is that we're running teacher professional development programs. One of the challenges we teach students to do is, suppose you have a drone that's sitting on one end of a table. How do you code that drone to take off, fly underneath the table, and land at the other end of the table? Karen asked, we thought about presenting to the annual Governor's Business Forum to educate the private sector and get them involved. I hadn't, but Karen, that is a fantastic idea. We started this project last year, but the truth is the pandemic caught us, and schools stopped hosting events. And so we're really at ground zero trying to figure out how to get this thing going. Our dream is to have drone teams at high schools all over the states. Karen also asked, are we talking to the Wyoming Department of Education? The answer is yes. The Wyoming Department of Education has given us initial seed funding to buy drones for schools and to pay for travel for our team of folks to go around the state to start hosting these things. Yeah, we're pretty excited about it. And this isn't nearly as expensive as running a robotics program. Robotics program, you're going to spend several $1,000s to get that robotics program going. For $100, you can get yourself a drone and you can start this thing. So, what's on our calendar? We just had an event scheduled in Laramie for 2 weeks ago. As it turned out, part of our drone flight instructor team came down with positive COVID tests, and we had to cancel that event, which was going to be held at Wyotech there in West Laramie. But the plan was to gather many GIS professionals and run an exposition, have public talks going on at this festival. We're not only doing drone racing, we're not only doing teacher education workshops, but we're also having community leaders come in and talk about their businesses, show the cool footage that they've created, to talk about how mapping is done, whether we're talking about DOT traffic work or rather talking about agricultural work, to really engage students and their teachers with professionals in the local community. Next month, we've got a teacher workshop going on in Gillette. We've got big events in Powell up in the Northwest in January, another big race going on in the Northeast in April, and we're going to have the first ever state championship in Buffalo, Wyoming on the 11th of June. And what we'd like to do is to have GIS professionals in those communities come out and meet the kids. They can help out by helping run the races. They can give public talks, wide variety of things. But particularly the software side is the most expensive, hard part. Schools can't afford expensive software, but if there are ways to share software with WIGIS, that's going to be absolutely amazing. So we're really looking for volunteers that can help us out with this.